Intelligent design and the demarcation problem in science. Some atheists claim that intelligent design is not science. However, they are unable to provide any clear hard criteria that would necessarily make intelligent design not science. In previous videos, I have shown that intelligent design matches all of the general requirements for a hard science. A. Empirical observation. B. Hypothesis building. C. Scientific method of abductive inference. D. Prediction. E. Testing by matching predictions to observations. F. Openness to falsifiability. G. Verification by matching prediction with observations. G. Iterative improvement based on observation and empirical feedback. H. Iterative improvement based on internal and external critique, feedback and dialogue. I. Confirmed predictions. J. No falsified core predictions. K. The paradigm providing fruitful pointers to new scientific questions. L. The paradigm providing fruitful pointers to new scientific areas of research. M. The scientific method of inferring a category of causes that matches uniform human experience. N. The scientific method of inferring a category of causes that matches uniform scientific experience. So, by any reasonable criteria, intelligent design is science. Therefore, it is foolish for atheists to claim that intelligent design is not science. In this video, I discuss yet another reason why it is foolish for atheists to claim that intelligent design is not science. This reason is the demarcation problem in science, i.e., philosophers of science are unable to provide clear rational hard criteria to say what is science and what is not science. And if philosophers of science are unable to provide such a clear demarcation criterion, why should we trust the word of some internet atheist who knows nothing of science or philosophy of science? The demarcation problem in science. Why it's impossible to draw a clear line. The demarcation problem in science refers to the challenge of distinguishing between science and non-science. It's a fundamental issue in the philosophy of science, and despite centuries of debate, philosophers and scientists have found it remarkably difficult to establish clear criteria that can definitively separate scientific inquiry from other forms of knowledge or belief. The crux of the problem lies in the complex, dynamic nature of scientific practice, which resists simple, universal definitions. Historical context. The demarcation problem has been a subject of philosophical discussion since antiquity, but it gained prominence in the 20th century, particularly with the work of Karl Popper. Popper proposed the criterion of falsifiability as a solution, arguing that a theory is scientific if it can, in principle, be falsified by empirical evidence. However, while falsifiability provided a useful heuristic, it soon became clear that it was insufficient as a strict demarcation criterion. For example, many scientific theories, such as those in physics or astronomy, are not directly falsifiable in the immediate sense but are instead supported by a network of interconnected hypotheses and background assumptions. Additionally, certain disciplines like psychology and economics often rely on models and theories that are not easily falsifiable, yet they are widely regarded as scientific. The problem of boundary cases. One of the reasons why the demarcation problem is so intractable is the existence of boundary cases, areas of inquiry that possess some characteristics of science but not others. Fields like astrology, for example, use empirical data and make predictions, yet they are not considered scientific by the majority of the scientific community. Conversely, areas such as theoretical physics sometimes venture into highly speculative domains, e.g., string theory, where empirical testing is currently beyond our reach, yet these fields are still considered scientific. The existence of these boundary cases suggests that science cannot be neatly categorized. Instead, it may be better understood as a continuum, with some disciplines exhibiting more scientific characteristics than others, but none possessing all of them in a way that allows for a clear-cut division. The role of paradigms and research programs. Thomas Kuhn and Imre Lakatos further complicated the demarcation problem with their concepts of paradigms and research programs, respectively. Kuhn argued that science operates within paradigms, frameworks of accepted theories, methods, and standards that guide research. Scientific revolutions occur when one paradigm is replaced by another, often without a clear, objective reason for the shift. Lakatos expanded on this idea with his notion of research programs, which consist of a hard core of central assumptions protected by a protective belt of auxiliary hypotheses. For Lakatos, a scientific research program is progressive if it leads to new predictions and discoveries, and degenerative if it fails to do so. However, this notion still does not provide a definitive criterion for demarcation, as non-scientific ideas can also form coherent and even progressive research programs. The social dimension of science. Another factor that complicates demarcation is the social dimension of science. Science is not just a collection of facts or theories. It is a social activity involving communities of practitioners who share certain norms, practices, and goals. These social elements, such as peer review, replication, and consensus building, play a critical role in what is accepted as scientific knowledge. This social aspect means that the boundary between science and non-science can shift over time as the scientific community's standards and practices evolve. For instance, disciplines like psychology and economics have allegedly become more scientific as they have developed more rigorous methodologies, yet they still face challenges in meeting some traditional scientific criteria. The impossibility of a universal criterion. The demarcation problem ultimately reflects the inherent complexity and diversity of human knowledge. Science is not a monolith but a collection of diverse practices, theories, and methods that have evolved over time. Attempts to establish a single, universal criterion for what constitutes science are bound to fail because they cannot account for the full range of activities that contribute to scientific progress. Moreover, the criteria that seem appropriate for one era or discipline may not be applicable in another. The scientific method itself is not a fixed set of rules but an evolving practice that adapts to new challenges and discoveries. As such, any attempt to rigidly define science is likely to exclude legitimate scientific work or include questionable practices. Conclusion. 1. The demarcation problem in science underscores the difficulty of drawing a clear line between science and non-science. The diversity of scientific practices, the existence of boundary cases, the role of paradigms in research programs, and the social nature of scientific inquiry all contribute to the impossibility of establishing a universal criterion for science. Rather than seeking a strict demarcation, it may be more productive to embrace the complexity and recognize that science, like other forms of knowledge, is a dynamic and evolving endeavor. 2. In previous videos, I have shown that intelligent design matches all of the general requirements for a hard science. So, by any reasonable criteria, intelligent design is science. Therefore, it is foolish for atheists to claim that intelligent design is not science. In this video, I discussed yet another reason why it is foolish for atheists to claim that intelligent design is not science. This reason is the demarcation problem in science, i.e., philosophers of science are unable to provide clear rational hard criteria to say what is science and what is not science. And if philosophers of science are unable to provide such a clear demarcation criterion, why should we trust the word of some internet atheist who knows nothing of science or philosophy of science? 3. Intelligent design is science. Thanks for watching. Please like, share and subscribe, and comment below if you agree or would like to add your thoughts.